Welcome to new session. Let us discuss refraction of light in detail again. Now today's concept is principle of reversibility. Refractive index of second medium with respect to first medium and refractive index of first medium with respect to second medium. Before that, in the previous lecture what we have studied, laws of refraction. First law was the incident ray, refracted ray and normal drawn at the point of incident all are lying in same plane. Second law is the ratio of sine of angle of incident to sine of angle of refraction is constant. That constant is called as refractive index, and that law was Snell's law of refraction. Already we have seen what is some limitation of Snell's law, that we have seen already. Now let us see. Let us see principle of reversibility. Directly, relation between refractive index of second medium with respect to first medium and relation between refractive index of first medium with respect to second medium. We define how to take absolute refractive index, how to take relative refractive index. Already we have seen that. Now, what is meaning of principle of reversibility? That we will see now. To understand this, let us take two medium again. One is rarer medium, second one is denser medium. Those are separated by some surface. Look at me here. Shall I take? I would like to take, this is one surface. See here, this is one surface separating two medium. So let us take this surface, I can call as xy. Xy is surface separating two mediums. Now let us take one more ray of light incident. Shall I take this medium is rarer medium? This medium is rarer. Let us take it, refractive index is N1. Fine. Now I can call this denser medium. This is denser medium, its refractive index is N2. Right around this. Now let us take a ray of light incident here. How to take the ray of light? This is one ray of light incident at this point. Right? Say this I can call PQ is nothing but ray of light incident at point Q. We know that the perpendicular line drawn at point of incident, this we are calling normal. Consider I can take the normal is nothing but MQ, M dash is nothing but normal. And what we know, when ray of light travels from rarer medium to denser medium, ray of light refracted towards normal. How this is? This ray of light refracted towards normal, like that. The ray of light is refracted along the direction of QR. Now, angle between incident and normal is called as angle of incident, and angle between refracted and normal is called as angle of refraction. Writing this. So, this refracted ray is going like this. Refracted ray is going like this. At the point of refracted ray, just I want to place a plane mirror. How to place a plane mirror? Shall I take here? Look at me. This I can take plane mirror. This I can take plane mirror. Right? When plane mirror placed in front of refracted ray, what happens? This refracted ray incident at point R and get refracted in same direction. See here. After incident, how it get reflected? It get reflected like this and goes back in the same path. Goes back in the same path. How it comes? The ray of light incident at point Q get refracted along direction of QR at the point R if a plane mirror placed so that this reflected light can bounce back in the same medium. Here principle of reversibility. Principle of reversibility says that after refraction and reflection the ray of light retraces its path. See here, ray of light incident get refracted along direction of QR, it get refracted. After incident on plane mirror, it get reflected back. Principle of reversibility says that after refraction and reflection, if the ray of light retraces its path, retraces means in what direction ray of light come, in the direction ray of light goes. In this direction ray of light comes, and after reflection the ray of light goes in the same direction. So that clearly I can mention principle of reversibility is after refraction and reflection, if the ray of light retraces its path, this phenomena we are calling principle of reversibility. Now, our point is, what is the relation between refractive index of second medium with respect to first medium and refractive index of first medium with respect to second medium? That we will see very simple. Look at me. Initially, The ray of light incident at point Q and get refracted. Ray of light comes from rarer medium to denser medium. When the ray of light comes from rarer medium to denser medium, shall apply Snell's law of refraction. How it is? When ray of light comes from PQ and get refracted along QR, what is Snell's law of refraction? Ratio of sine of angle of incident to sine of angle of refraction is constant. But constant is we are calling refractive index. How to take refractive index? Refractive index of second medium with respect to first medium. Refractive index of second medium. Refractive index of second medium with respect to first medium. Refractive index of denser medium with respect to rarer medium. Now I can call this is the equation number 1. Right thing. Now, when ray of light incident at this point Q and get reflected back, how it get reflected? Reflected along direction of RQ and go refracted along the direction of QR. Now, when ray of light goes back, this becomes angle of incident and this becomes angle of refraction. Again, shall I? When ray of light travels from denser to rarer, how to take? This becomes angle of incident, this becomes angle of refraction. Shall I take here? When ray of light goes from denser to rarer, ratio of sine of angle of incident to sine of angle of refraction is constant, because this becomes angle of incident, it goes like this now. Now, refractive index of second medium with respect to first medium, refractive index of rarer with the denser. Rarer with the denser mean how to write? Refractive index of rarer medium with respect to denser medium. Now I can take this is what? Equation number 2. What I need? I need relation between n21 and n12. See here. Simply multiply equation 1 and 2. What will get? Sin I whole divided by sin R into how much? Sin R whole divided by sin I is equal to refractive index of second medium with respect to the first medium into refractive index of first medium with respect to the second medium. Then what I need? Sin I get cancelled, sin R get cancelled, remaining 1 only. How to write? Refractive index of second medium with respect to the first medium into refractive index of first medium with respect to the second medium is equal to 1. Then what we got? Refractive index of second medium with respect to the first medium is equal to reciprocal of refractive index of first medium with respect to second medium. So this is what? Relation between refractive index of second medium with respect to first medium is equal to reciprocal of refractive index of first medium with respect to second medium. Remember this point. So this is what? Principle of reversibility and relation between n21 and n12. Now after this, let us take one more concept, refraction through glass slab. That concept we will see. See here. Let us take refraction through glass slab. Okay. Refraction through glass slab. Through glass slab. Concept of lateral shift. Lateral shift. That we will see. What is meant by lateral shift? Okay. Refraction through glass slab. See, this concept is very important. How to take refraction through glass slab and what is meaning of lateral shift. This concept we will see now. To understand this, now let us take a glass slab of thickness T through which ray of light is refracted. Shall I take here? I can take this is nothing but glass slab. Consider this is the glass slab. This is glass slab. This glass slab of thickness T available. Let us take this is thickness, right? Thickness T. Now on this glass slab, consider the ray of light incident and get refracted. How this is? We know that. So this is radar medium. Say it is air medium, and it has refract index. What value? Refract index is German. And this is glass. This glass has refractive index of what value? N2. And this is denser medium. What I can call this is denser medium. Glass is the denser medium because glass has refractive index 1.5 around and air has refractive index N1. So it is called as radar medium and this is called a denser medium. Now let us consider the ray of light incident. How it is? Shall I take here? A ray of light incident. I can call this nothing but ray of light. This ray of light incident at point Q. Now what you can call PQ is nothing but incident ray. Then perpendicular line drawn at point of incident. This I can call normal. Perpendicular line drawn at point of incident we are calling normal. We know that ray of light travels from radar to denser, so that this ray of light refracted towards normal. Like this. Like this it is. How it is get? Refracted ray, the ray of light is refracted along the direction of QR. What we know? Angle between incident ray and normal is called as angle of incident. Angle between refracted ray and normal is called as angle of refraction. Right. Now, we know that the ray of light incident forward direction. How it is? This is nothing but incident ray. If this incident ray produces in forward direction, how it goes? It goes like this. Like this it goes. Like this. How the ray of light produce? Incident ray of light produce like this. Right around this. I can take it is normal. What about this one? Shall I take? N, Q, N dash is nothing but normal. Now, when ray of light incident at this point, so again we are calling normal. Shall I take it is normal? How to take? Again we are calling this is normal. But this is nothing but denser medium. When ray of light travels from denser to rarer, how it get refracted? It get refracted away from the normal. How it get refracted? It get refracted along the direction of RS. This angle I can call angle of emergent. Shall I take it as angle of emergent is nothing but I dash. Angle of emergent is I dash. See here, we are calling this angle of emergent I dash is equal to angle of incident ray. Then the incident ray is said to be laterally shifted. Angle of incident is said to be, or the ray of light is laterally shifted if the case angle of incident must be equal to angle of emergent, then the ray of light is said to be laterally shifted. Initially we will see what is meant by laterally shifted, then we will say lateral shift later on. See here. We know that the ray of light incident at an angle I and get refracted at an angle R. And the ray of light goes from radar to denser. What about refractive index? It is N2. Right on this. Now, let us apply Snell's law of refraction when ray of light goes from radar medium to denser medium. According to Snell's law of refraction, what you can take? Ratio of sine of angle of incident. Ratio of sine of angle of incident to sine of angle of refraction is constant. Refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. Right around this. Now I can take it is equation number 1. Are you following this? Now, the ray of light incident at this angle now. At this angle. If the case this angle equal to this angle now. Shall I take this angle is equal to R value? Because this angle equal to this angle. Ray of light incident at this point and get refracted. Now ray of light goes from denser to rarer. Denser to rarer. This becomes angle of incident. This becomes angle of emergent. Right thing. Let us apply here. When ray of light comes from denser to rarer. Denser to rarer. See here, ratio of sine of angle of incident to sine of angle of refraction equal to constant. But how to take? Now again it is air medium that I can take refractive index in one, here also in one, here also in one. Now refractive index of second medium with respect to first medium, refractive index of second medium with respect to first medium. See here, shall I make it reverse one? Reverse mean, now simply I can take sine I dash divided by sine R equal to refractive index of second medium with respect to first medium. Reverse I taken. Actually distance law I taken reverse value because I need this. Now just compare equation 1 and 2. Compare equation 1 and 2. If you compare this one, then what you are getting? See here n21, here n21. Then what about equation 1 and 2? Sine I whole divided by sine R equal to sine of I dash whole divided by sine R. Sine R get cancelled. What is remaining then? Remaining what you are taking? Sine I is equal to what value? Sine I dash. See here. Then what you can taking? I is equal to what value? I dash. What is I? Angle of incident ray. What is I dash? Angle of emergent. If angle of incident equal to angle of emergent, the incident ray is said to be laterally shifted. Incident ray is said to be laterally shifted. Right. Now I need the concept of lateral shift. What is meaning of lateral shift? That we'll see. See here. Already we know that this is incident ray produced. Later on this. Ray of light comes from rarer medium to denser medium. Angle between incident ray produced and refracted ray. This we are calling angle of deviation. This we are calling angle of deviation. See here. Sum of angle of refraction and deviation must be equal to angle of incident. When ray of light travels from rarer to denser, what we know the relation? Angle of deviation is equal to I minus R. Already we have seen in the last class. See here. Angle of deviation. How it is? R plus D is equal to I, or D is equal to I minus R. I minus R. Remember this. Right. I need lateral shift. Meaning of lateral shift. See here. Ray of light refracted at this point. If you draw a perpendicular line to incident ray produced. See here. Perpendicular, which one I can take? I can take one more perpendicular. Say I can take RSR. RD I can call. RD perpendicular to incident ray produced. RD perpendicular to incident ray produced. So this I can call lateral shift. Lateral shift. What is lateral shift? The perpendicular distance between incident ray produced and refracted ray. How it is? Perpendicular distance between incident ray produced and refracted ray is called as lateral shift. This lateral shift can be represented by L. Right. I need expression for lateral shift. What I am saying? Perpendicular distance between incident ray produced and refracted ray is called as lateral shift. See here. This lateral shift expression we will see. Lateral shift that is represented by L value. How will see? Look at me. QRD looks like one triangle. QRD looks like one triangle. Shall I take here? Triangle. QRD looks like one triangle. In this triangle, I can take sine theta. What is sine theta? See here. Sine theta is equal to opposite by hypotenuse. What theta available? That is D, or D is equal to I minus R. From that, shall I take triangle? See here. From that triangle, I can take sine I minus R. Sine I minus R. Sine I minus R is equal to how much? That is RD divided by how much? RD divided by QR. RD divided by QR. Or is. See here. RD is equal to how much? RD is equal to QR into sine I minus R. What is RD? This is RD. This perpendicular distance second called lateral shift. So lateral shift L is equal to how much? L is equal to QR into how much? Sine I minus R. Sine I minus R. Now I can call this is equation number 3 from this. one more triangle is there. Which one is triangle? Q N dash R looks like one triangle. Q N dash R. See here. Triangle Q N dash R looks like one more triangle. So in this triangle, angle of refraction how much? That is R. Again from the second take cos theta is equal to adjacent by hypotenuse. See here. From that I can take cos theta mean cos R I will take. Cos R is equal to how much? Cos R is equal to Q N dash whole divided by Q N dash divided by how much? That is QR. Right? R. What is QR from this? QR is equal to Q N dash whole divided by cos R. But Q N dash equal to thickness of the slab. This side must be equal to this side. So that how to take again? QR is equal to T divided by cos R. Let us call equation number 4. Now put equation 4 in equation 3. What we will get? QR is there here. See here. Lateral shift how to take? L is equal to QR. QR is this value. T into how much? Sin I minus R whole divided by how much? Cos R. This I can take lateral shift. Expression for lateral shift. If the case I is equal to R. If I is equal to R, then T is equal to 0. L is equal to 0. If angle of incident is 90, then angle of refraction is nothing available. So that L is equal to R. When L is equal to T, if see here, I is equal to R means sin 0 by any value 0. L is equal to 0. One case. But when ray of light going along the normal mean, so angle should be equal to 90 degree. Then I can take lateral shift is equal to what value? T. One case. If the ray of light incident along the normal, then L is equal to what value? T value. Right thing. So this is what concept of lateral shift. How it is? Simply perpendicular distance between incident ray produced and refracted ray is called as lateral shift, and this we are calling expression for lateral shift. Later on, let us take some examples for refraction of light. What are applications of refraction of light? We know that when pencil is placed inside the water, the pencil appeared to be bent. When coin placed inside water, the coin is appeared to be raised. All these are nothing but examples or phenomena or applications of refraction of light. Now, one of the application of refraction of light that we will see, that is the coin is appeared to be raised when it is placed inside water. That concept we will see. That is concept is apparent depth, real depth and normal shift. That we will see. See here. After this, let us take one more phenomena. Okay, students. Now concept is real depth, apparent depth, and normal shift. Apparent depth and normal shift. Normal shift. See here. This phenomena we will see. Correct. To understand this, now let us consider a coin is placed inside water. When the coin is observed from other medium, the coin is appeared to be raised. Right? That phenomenon is nothing but due to refraction of light. Now, shall I see here? Consider the coin is placed inside water. I can take this is nothing but water. This I can call water medium. and this is nothing but level of the water. See here, this is nothing but level of the water. Are you following? So here water is available, this water has refractive index N2, like this. Right. This is the level of the water I can take. This is the level of the water. Now inside water consider a coin placed. This is the coin. The coin available at point O. Great thing. When ray of light goes from this coin perpendicular, the ray of light never deviated, because already we know that when ray of light goes perpendicular to surface, the ray of light is never refracted. Instead, the ray of light goes same path. How it is? If the case the ray of light it goes perpendicular to surface, so that this ray of light never refracted. How it goes? It goes like this. How it refracted? The ray of light goes along the direction of OA. Then this OA we are calling real depth of the coin. OA we are calling real depth of the coin. One more ray of light that is going from the coin at an angle of incident I. How this is? Shall I take here? Let us take one more ray of light. This is one more ray of light incident like this. Perpendicular line drawn at point of incident we are calling normal. Are you following me this? Right or wrong? Let us take the ray of light incident at an angle I. How it goes? This is the ray of light incident like this. So the ray of light going along the direction of what value? OC. After refraction, the ray of light goes like this. Like this ray of light goes. The ray of light going along the direction of CD. Remember this. Fine. This becomes what? Angle of refraction. This becomes angle of refraction. The point is, when refracted ray going along the direction of CD, at the point of refracted ray, any observer stands and look the refracted ray. Actually, what is the real depth of the coin? AO we are calling real depth of the coin. But whenever observer stands here and look the refracted ray, where the observer stands, shall I take here? I can take, let us consider observer stands here. He is the observer. Observer stands here and this observer looks the refracted ray. Look at it. It is the observer. When observer sees the refracted ray, this ray of light meets some other point. How it goes? See here. Whenever observer looks this refracted ray, how the refracted ray can come? Refracted ray can come at this point and meet here. At what point? It can meet at the point I. At the point I. Then the coin is appear at point I instead of at point O. How it is? Whenever observer looks the refracted ray meets at this point I. Then the coin is appear at point I instead of point O. Then the distance AI is called as apparent depth. Distance AI is called as apparent depth. See here in this figure, this AO we are calling real depth, AI we are calling apparent depth, and IO we are calling normal shift. How it is? Look at me. See here in this figure, AO what you are calling real depth, and AI apparent depth, and IO is nothing but normal shift. Normal shift. Here this AI is called as apparent depth. Apparent depth, how to define? Shifting position of the object due to refraction of light. Shifting position of the object due to refraction of light, that we are calling apparent depth. See here in this figure, if the case this is angle of incident, then this also angle of incident. See here, sorry, this also angle of incident. Look at me, this also represented by I. If this is angle of refraction, this also angle of refraction. How it is? Angle of refraction can be represented by R. Right or wrong? Then I need what is the relation between real depth, apparent depth and normal shift. Real depth, apparent depth and normal shift. That we'll see. See here. Before that, the ray of light goes from denser medium to rarer medium. Ray of light goes like this, ray of light goes like this. What about this? This second called denser medium. This second called denser medium, and what you are calling this is rarer medium. The ray of light goes from denser to rarer. Are you following me? See here. Let us apply Snell's law of refraction. Ratio of sine of angle of incident to sine of angle of refraction is constant. Refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. Following me? Because ray of light goes from denser to rarer. If the case ray of light goes from rarer to denser, this is represented by 2, this is represented by 1. Right? Now let it be. So I can call this is equation number 1. Remember? So I can call it is rarer medium. This rarer medium shall I take it is air. And what about this? This I can take water. I can take this is water. Right thing. Now in this figure, two triangles are looks like. One is AOAC looks like one triangle, and AIC looks like another triangle. Shall I take one triangle here? Look at me. Triangle OAC looks like one triangle. In this triangle, shall I take sine theta? Sine theta mean what value? Sine theta is equal to opposite by hypotenuse. See here, how to take sine theta, sine I. From this one, shall I take sine I? Opposite by hypotenuse, sine theta. See here, sine theta, sine I. Opposite by hypotenuse. Opposite is equal to what value? AC. Hypotenuse is equal to what value? OC. Again, one more triangle looks like. One more triangle. Which is triangle? AIC looks like one triangle. AIC looks like one triangle. AIC looks like one triangle. From this triangle, shall I take sine R? What is sine R? Opposite. Opposite mean AC. AC whole divided by hypotenuse what value? That is IC. Write down this. Now I need sine I by sine R. Look at me, sine I by sine R. How to take sine I by sine R? Sine I mean what value? This value. AC divided by OC. Sine R. What is sine R? Sine R is equal to how much? IC divided by what value? AC is equal to refractive index of first medium with respect to the second medium. From equation 1, I put the value of sine R and sine R. AC get cancelled. What is remaining then? IC divided by OC is equal to refractive index of first medium with respect to the second medium. But look at me. One more ray of light goes like this. One more ray of light you can take like this. Like this. One more ray of light you can take. Light you can take number of ray of light. Not only this ray. Not only ray OC. How to take? Ray of light can take like this. Ray of light can take like this. Number of ray of light can take. So that the point C is very closer to point A. What we can assume here? The point C is very closer to point A. See here. C is very closer to A. So that I can take C is equal to A. C is equal to A. See here. If C is equal to A, how to take this figure? Simply A can be replaced by C, AI. And what about that? That is OA is equal to refractive index of second medium with respect to the first medium. Or else, shall I take reverse value? Reverse mean OA divided by AI is equal to refractive index of, see here, this is first medium with respect to the second medium. But I can take reverse value. Reverse means refractive index of second medium with respect to first medium. Refractive index of denser with respect to air. I am taking just reverse value. Then what you getting? See here. Or else you can take like this also. OA divided by AI is equal to what value? N2 divided by N1. What we know? N1 is the rarer medium, air or vacuum. Its value is 1. For my convenience, I will take air is equal to 1 value and N2 is equal to what value? N value. N2 is equal to 1 value. N1 is equal to 1 value. N2 is equal to N value. Then what about this equation? See here. OA What is AO or OA? Real depth. Real depth. AI. What is AI? Apparent depth. What are calling this? Apparent depth is equal to what value? N divided by 1. Or else real depth divided by apparent depth is equal to refractive index. Shall I take directly here? I can take real depth whole divided by apparent depth. Whole divided by apparent depth. Apparent depth equal to refractive index. How it is? Refractive index of denser with respect to error. If we take refractive index of denser with respect to error, then we are taking real depth divided by apparent depth is equal to what value? Refractive index of the given medium. But look at me. From this figure, again I need relation between normal shift and apparent depth. See here, in this figure what you are taking? AO is called as real depth, AI is called as apparent depth, and OI, it is called normal shift. From this figure, how to take normal shift? See here, if I need IO, then you can take AO minus AI. AO minus AI. How to take here? Look at me. See here, from this figure, how to take? From that figure, you can take IO. IO is equal to what value? AO minus AI. AO minus AI. What is IO? It is called as normal shift. AO is called as real depth and AI is called as apparent depth. Right around this. But here again I need relation. Real depth is equal to what? Real depth is equal to apparent depth into n value. See here, from this figure how to take? Real depth is equal to n into apparent depth. Right? Then what is normal shift here? Normal shift is equal to real depth. Real depth is equal to n into AP. AP means apparent depth. Minus of what value? Apparent depth. Right thing? Look at me. Once again I will take. Real depth is equal to what value? N into AP. N into AP. Real depth. See here. Normal shift is equal to real depth means this value n into AP minus of what value? AP is common here. Then what is normal shift? Normal shift is equal to what value? N minus 1 into apparent depth. This is the relation between what? Normal shift and apparent depth. This is relation between refractive index and real depth and apparent depth. Refractive index is equal to real depth by apparent depth and normal shift is equal to n minus 1 into apparent depth. So this is concept of principle of reversibility, real depth, apparent depth and refraction through glass slab. Further concept we will see in next session. Thank you.